Hi, Pew. Do you know that you are always too close to the camera? Then why don't you just always find some good distance from the camera? Do you know the way to do it? Do you mind I teach you how to keep the right distance? Okay, then first you back up a little bit. Then we can start the tutorial. Let's use the Sonar sensor in front of you to find the right distance to the camera. And we can write a program to do it. How about that? Okay, let's do it. Let's talk about the sonar sensor. There are two ports in a sonar sensor. One, it is the emission port. The other one is the receiving port. When the sound emits from the emission port and bounce on the table and bounce on obstacles, then the sound will echo back to the receiving port. The timestamp of receiving the echo minus timestamp you emit the sound wave can be used to calculate how far away is the obstacles. Now let's go to the programming part. So all the programming material tutorials that's in the Story of Pew book 3 Growth and Learn JavaScript with Robot Pew and the summary Sonar beacon. In these tutorials, basically we're going to implement something like a ping signal in a summary. The idea is we're going to map the distance of the obstacles to the sound frequency of the ping and also how often we emit the ping. So the effect it will make the Robot Pew looks like a submarine. Before we go to the program, we want to introduce one concept called variables. This is the first concept in important concept of programming. So a variable, basically it is a name of memory space in a program used to save the data. And the reason we need variable, it's sort of like the name of the address of your house. So nobody remember the like a GPS location of your house, but they know the street number. Or you can give a really good nickname about your house. For example, like a Disney house, say a Little Pony house, something like that. So it's easier for you to memorize where is your data. And for each variable, there is a data type associated with it. It could be a number, or could be a string. So, and to create a variable in microbit, you can use the interface to say you go to the variable, click the variable menu, then you can create a variable, then make a variable, give a variable name, then after that you can set the variable to a number, or there's an interface you can change the variable by some number. In our cases, we are going to save the sonar distance in a variable such that it can be reused. So if we got the time, read through my teaching material one by one, and then you can go to the our programming site. So let's open the tutorial. So first you can go to the this program and click edit. Let me explain the program one by one. So when we load the program, as you can see, we already load the robot view extension here. So say the first, let me turn it off. Like the first three blocks, what you learned from last session. It set the channel number, and also receiving the gamepad command and takes action. And today we basically going to learn this program. In this for level group, as you can see, we set the sonar distance to a variable called distance. So you can find a distance at here. You can make it variable like this, then type in a distance, then you can see the distance showed up here. And how do you get the sonar distance value? You go to robot view and sensors, then you can see at here you got a sonar distance. You can drag it out to here and assign it to the sonar distance. So according to the logic here, so we are saying distance, if distance bigger than 2 or less than 100, then we do something. The reason we doing that, it is the sonar sensors sometimes return a value doesn't make sense. We only trust the distance get from a sonar sensor between the 2 centimeter and 100 centimeters, and then we ignore the rest of the values because they're not trust. So then logic here, it is if the distance is bigger than 2 and less than 100 centimeters, then we're going to map the sonar distance sensor from 2 to 100 to the frequency 2000 and 200. The map, you can get the map function from the math session. As you can see at here, you can map a value. The value you can get, it is, you can drag for distance here. You map distance from if the distance is 2, then we map to frequency 2000. If the distance it is 100 centimeters, we map to frequency 200. So in this way, it is called reverse mapping, inverse mapping, because we map a low value to a high value, a high value to low value, and we do this kind of mapping based on what you need, right? So the reason we want to map the low distance to high frequency, it is usually high frequency means danger. Okay, so and you can see at here we have another map. We map the time interval between each beep playing to distance as well. So we map, if it is short distance like 2 centimeters, we map to shorter interval. That means when the obstacle is getting closer to the objects, you will not only hear the frequency is high, but also the time interval between each beep is shorter. So the next line, we set beeping volume to the maximum 255. Then we call a method to play tune with the pitch we map to from the distance. Then we paused for some delayed. So that means to control the time interval between the beep. So basically that's the logic to make the sonar beeping, control the sonar beeping frequency and a time interval. And then the next session, it is in a different forever loop. We map the walking speed to the distance as well. The closer the distance, the lower the speed. At here we map 7 centimeter to -1. That means if it is too close. So it says 7 centimeters. So the robot will walk backwards. The negative speed means negative, means go backwards. So in this way, we can control the robot in such a way that when the robot is far away from the obstacles, it walk fast. When it's getting closer to the obstacles, it slows it down. If it's even too close, you will go back. That's it. So that's basically the program to control robot Pew to move to obstacles. And here the obstacles is the camera, and stop at the right distance. And how far away you want to stop it is controlled by you. And here, if you increase this number from 7 to like 20, and this number to 20 to 40, then the robot Pew will stay away from the camera we keep the longer distance from the camera. Now let's play a fun game called Bonk. The game rule it is in a different book called Book 2, the game session, and there's Explore War with Robot Pew. There's one thing called Operation Bonk. The setup of the game, it is we put a robot in front of the wall. Say the rule, it is you write a program, try to make the robot stop as close as possible to the wall. If the distance to the wall is the same, then the robot reach the stop first and win the game. Okay. In order to win this, change to the program. The main idea it is to make the beeping to indicate the distance of two obstacles is not important anymore. We just need to remove those code. Okay. So for example, in this code, let's go back to here. See, we get rid of most of the code. We didn't map the distance to the beeping frequency and the beeping interval anymore. We just focus on map the distance to moving speed. So we only have two lines of code. Get distance, then map the walk speed to the value you want. And here we map the 7 centimeters to -1. And in order to win the game, you have to tweak the number 7 to a value your robot can stop in front of the wall without touching the wall. As for this part, it is a black magic because every robot is different. You have to find out the right number for your robot to win a game. And the other trick to win it is how do you tweak the mapping relationship. You can map the short distance to a negative speed. You can make it backup sooner. When you want to make backup sooner, you have to increase the -1 to -2 ish. But that requires quite a bit tweaking. Let's see how well we can tweak the program and have fun to play with the Bonk game. Now let's see how the program works without those beeping, and the robot Pew should walk to the wall silently. Here, let's see this time whether you can find the right distance in front of the camera. Here, what's going on? Do you know that you are still too close to the camera? So why you still want to do that?
Because he loves camera.
Because the Don't Bonk game says the closest to the camera win the game.
Robot Gyms.